We'll do that one. Actually, that one might be able to be adjusted a little bit. And actually, tell you what, let's do this. I don't even know what that thing is. There, that's good enough. It has a dot in the middle of the screen, but that's okay. Blackboard. Is this the most bizarre class you've had?
Sadly, no.
Do what?
Sadly, no.
Oh, really? I wish this thing would have never happened, but what it's done for me is I've learned all sorts of different techniques here. Do you mind if I go into this? Oh, no, that's the wrong week. Do you mind if I go ahead to week 8? Or do you want to, should I go back? What do you think?
Stick with it.
Okay, all right. Let's do it. Okay. I think I did that one online last time. That's, I guess, today's Wednesday, so that would have been Monday. Oh, wait a minute. Am I getting any audio? Am I getting, there is some audio. I don't know where it's coming from. Apparently it's coming from this thing. So there we go. I'll strap it to that. Now the question is, yeah, I did this one because I remember the Omega. But you know what? I didn't do it the long-handed way. So you know what I'll do? I'll do it the long-handed way. Okay, here we go. Looks like we're moving. So, long-handed way. It says, determine the angular velocity of link AB at the instant shown if the block C is moving upwards at 12 inches per second. And everything looks like it's in inches. So, I guess that's probably okay. Maybe I could make it go down a little bit. That's probably good. So, there are 2 links. Oh, no, you're kidding. Ah, crap. Okay, oh, wait. Okay, all right, good. Okay, so there are 2 links. Link AB and BC, in which B is common to each of those. So you can write the equation, velocity of B is equal to the velocity of B relative to A plus the velocity of A. In this case, in most cases in which it's pinned to the ground, that one goes away. And this one comes back to, now, I'll go ahead and write the other one over here, velocity of C equal velocity of C relative to B plus velocity of B, because these are on their own link, these are on their own link. But it just so happens B is common to both. So, how do we, what is that thing? It doesn't go away. There we go. So, in this one, and in the book he'll talk about it, this one is a vector omega AB, which is what you're looking for, crossed R beta A. And then plus 0, but we're just not going to write 0 anymore. So we're just going to leave that off. And the way I look at these things is this. Everywhere, okay, so here. I always use an X and a Y. And if that's the case, you can take the right-hand rule, and the Z is coming at you. So a twist like that is what's commonly a positive twist, or a motion like that, which that's what this one is. He's written it that way, but he didn't tell you what it is anyway. So I think generally in the book he'll write them in a positive sense. So the way I do these, now the book he does them a little bit different, but I like to set up the little matrix in which the first row is the omega. This is the scalar version. Oops. This is the number, that's the vector, so it sounds weird, but omega AB is equal to omega AB, which is different. It's like a number times K. So it's a twist coming towards you. And so in this particular case, I'll write it over here. The vector is equal to omega AB, a scalar number times K. So now that you have that, the next thing is the RB pointing to B, originating from A. So that's a vector that comes like so, and that vector is R pointing to B, originating from A. So this is where, so you can put it like this is the arrowhead. You know, in a CAD drawing, you can do that, you can put vectors. So this is, what is that kind of called? The tail, right? No, that's the head, so this has got to be the tail. This is the tail of the vector. This is the arrowhead for the vector. And so with that, and I've boogered it all up there, so I'll write it right here. R beta A, if, in fact, can I see all that? Yeah, I think so, actually. R beta A equals to, going to the right, 5 over square root of 2i, going down, minus 5 over square root of 2j. And the reason it's 5 square root of 2 is it's that, so in other words, that's 45, that's 45. They should be the same length. So you could say this is 5 cosine 45, but that's 1 over square root of 2. So you end up 5 over square root of 2. Turns out you end up with the same thing there. Over square root of 2 there. So you end up with, see, going to the right, 5 over square root of 2, going down, 5 over square root of 2. Oh, and 0. The vector isn't going into or out of the plane. It's planar motion. So what you end up with, the I minus the J. And I guess I could put K, but this part of K is 0, 0, 5 over square root of 2, 5 over square root of 2. So there is never going to be, in a case like that where you have planar motion, there's never going to be a velocity moving in the direction. So if you have a rotation, you never have velocity in the direction of the rotation. So this point isn't moving into or out of the board, it's only moving in that same plane. So you have I to be 0, omega AB, 5 over square root of 2, and 0, and then you get, oh, I'm sorry, error. Let me redo that one. I'm removing, oh, okay. I didn't have to erase, I could have just put the minus. So I'm looking at the I, so I eliminate the row, the column, this and this. Omega AB and 0. So I should be taking that one, putting it here, taking these two, and putting them there. So, with that, you can erase this one because there's no K component. I don't know what's going on here. The eraser doesn't work. So what you end up with is you end up with that number, which is nothing, minus this number multiplied, but there's a minus already, so you get a 5 square root of 2 omega AB I. This one becomes that, well, that's going across here, so it becomes a minus, but there's a minus there. Now, does that look right? J. And let's see, if it is rotating like that, then this vector should, actually, this is kind of not the scale, because this is 30, so I don't know, the aspect ratio of the projector doesn't look quite right. I can even tell that the lines are kind of skewed a little bit, but it's kind of up like that. This is 90 degrees, and this is 45 here, so it turns out this is going to be 45, and a line to here is going to be 45, and it's going to go in the positive X direction and the positive Y direction, and they're going to be equal. So at least I know that. They're equal, and they're both in the positive direction. So at least I have a good sense that those are correct. Does that sort of make sense? It's all recorded in the video anyway, I hope. Let me double check. I have to cut off the volume. Ooh, unfortunately, there's a big, like, spot right here. So you know what I'm going to do? I'm going to try, it looks like, right here. This might be a good idea to start the lecture this way. Find the spot, like right here is a reflection. Let's see if I can, I'm watching myself. I'm about 5 seconds delayed. Okay. Well, that's pretty close. Oh, that's pretty good. So the reflection actually goes up. All right, so this is a no right zone. So, because it's the lamp producing a reflection right there. Okay. So what I'm going to do is take this, put up here, and then do this equation because I don't have room. So I'll take this one, put up here. So from that, I got velocity B as a vector equaling to 5 over square root of 2I, and then, with the omega, sorry. Omega AB ABJ. Okay, so I copied that to there. I'm gonna erase all this. I'm gonna do that one. And I don't know what's going on here. Let's try to see if that does better. No, it doesn't. Oh, I know why this is doing it. The room is cold. When it gets cold, these markers, they don't erase very well. Rooms are hot or cold. Okay. So velocity of C, I'm just rewriting the same thing. Velocity of C relative to B plus this one, which is velocity of B, which I'll copy in a second, but I'm going to carry it as velocity of B for a while. And then, like in the book, omega BC, the rotation of this length, which in the video last time, we found out that it appears to rotate up around somewhere like right around in here. Actually, let me be precise about that. Okay. I'm going to leave that there. So actually, it appears to rotate about that point. The reason being is because if you draw a line, that's perpendicular. And if you draw a line here, even though it does rotate about here, a line from here to here, this is 90 degrees from that. So this is what they call the instant center. So any 2 points, there's an odd body. One velocity might be going here, the other one's going here. You know the direction of 2 of velocity points. Draw a perpendicular to that and look for where they cross. That is what's called the instant center of rotation, or the center of rotation at that exact instant, which means it appears at that instant that it's rotating about that point. Then you can start doing stuff like this. What's that velocity? Or what's this velocity? And all you got to know then is the distance from here to here, and the distance from there to there. That's in the video on Monday. And I think I worked this same problem that way. And I used some CAD stuff in there to be lazy about it. But, oh, geez. Okay. But we're doing it the longhand way here. I'm just going to carry that. I do not know. Okay, this is what appears to be omega BC. It's the rotation about C. I'm drawing it in the positive direction. It's probably going to be positive. JK 0, 0, omega BC, because it is rotating in the Z direction. Then I just need to draw a vector with an arrowhead at C and the tail there at B. So what I got to do is draw this vector. That vector is R pointing to C, originating from B, and it's nothing more than 4 cosine 30 I 4 sine of 30, j. So I will use it in here for cosine 30, and it's under the I, for sine 30, and it doesn't have a component going into or out of the board. And I really don't want to deal with this quite yet, but I'll put that in there in a minute. So if I do a cofactor expansion here, this is gone, so I take 0, make it be C, for sine of 30, 0 minus j, for, did I do that right? Cosine 30, 0. And there isn't a k, but if I felt like writing it, 0, 0, 4 cosine, 4 sine 30, those are going to go away because these two are going to knock out those, and there is no k component. So I'll just be lazy and remove it, and then I'm just still carrying this down as a vector form. I'm obviously going to have to copy it back up here and do it back down again, because, let's see, 0, 0 to 0 minus 4 sine 30 omega BCI, that minus that, a minus gives me a plus for cosine 30 omega BC J. Now I'll add that. Well, no, I'll do it one more time. Now I'm going to take this and copy back up to here and then come back down. So let's see. Everything is visible. Yeah, you can see everything. Okay, copy that back up to here. I'm just going to stick it in here, and it's going to be minus 4 sine 30 omega BC I plus 4 cosine 30 omega BC J. Why did it become bigger? And then plus, now I'm going to include this. So this gets copied up here. 5 over square root of 2 omega AB I plus 5 over square root of 2 omega AB J. Now I've got the whole equation, so I'm going to start erasing that underneath it, and I guess that was a compressor. Okay, so now I've got an equation, and I got all this room under it. What do I do with it? Well, in the initial thing, he's told us the block C is moving upwards at 12. So this is the key. It's 12J. So the velocity C is moving up at 12J. That being X, and this being Y. And so Now, instead of rewriting it again, I'm just gonna do an erase the 12J. And now what I'm gonna do, I guess I could say this, okay, let me be legal. 0I plus 12J equals 2. So now if I identify all the ones that have an I component, I'll start there. So the I components is 0 equals 2. Minus 4. I'm going to put the omega in front of the sign. Omega BC sine of 30. Then the other one, which is plus 5 over square root of 2, omega AB. I don't have to list the I, so that's an equation. This has to be satisfied. 0 has to be this plus that. So somehow omega BC and omega AB have to go together such that it forces each other to be 0. I'm sorry, not each other, but the equation itself. J over here, now look for just the J's. So just the J's are this one, and this one. And 12 equals 2. 4 cosine, well, let me put the omega in front. 4 omega BC cosine 30, and then plus 5 over square root of 2 omega AB. Make sure I got that right. 12. Wait, no, for this one, and then that one. Now, if I do something like crazy, like I take the upper equation and change the signs, make that plus and that minus, and I could say I changed the sign over here, but there's not one, and then add the two equations, I get 12 equals 2. 4 omega BC cosine 30, plus sine 30, and then nothing. That and that cancel each other out. So now I get omega BC equal to 12 divided by 4 cosine 30 plus sine 30. Okay, so if you got sine 30, this is 30 degrees, and this is the length. This is L over 2, and this is 0.866 L. So actually, if you add the cosine and the sine together, you get 0.5 and 0.866. And so this whole thing becomes 12 divided by 4, let's see, is that 1.366? 0.5 in that, I think so. So let me see if I can make my calculator come up. The 12 divided by 4 divided by 1.366, 2.19? Uh-oh, I think that's wrong. I think it is. Uh-oh, what do we do? Uh-oh, it's 1.24. So, the answer, omega BC, is equal to 1.24. No, wait, no. That's omega BC. I didn't find omega AB yet. Okay. So I might not be wrong. So that's Omega BC. This is not, this is the Omega AB. Not sure I'm wrong yet. So now, if I take this equation and move that over, so now I take this and this together to get 4 Omega BC, which is about 2.19. There were extra digits. Sine of 30 equals to 5 over square root of 2 Omega AB. So what I'm doing is I'm combining this equation with this number, Omega BC, and so Omega AB should be equal to 4, 2.19, sine of 30 is a half, divided by 5 times the square root of 2. So, good grief, times 4, times 0.5, times square root of 2, divided by 5, 1.24. So that's the longhand way to do it. So, I know that may seem boring, and I don't think I have time to do another one. You know, the other camera does not have that reflection spot in it. Okay, so now I've got that reflection spot. If I go to the other, all right, if I do away, okay, where's the other camera? Not that one, not that. Oh, I should have used the other camera to begin with. Except the projector's in the way, and it blocks the spot right there. So I either get a big blocked region right there, or a little reflection region right here. So, oh well. Okay. I'm gonna go ahead and stop the stream.